It's September the 1st, 2015. It's 4:30 a.m. I'm still observing the irregular movements in orbital path of the moon hologram, an orb cluster, Nucleus. There's that X shape I'm talking about, and it's still full moon. It's been a week now, at least, that it's been full moon. Okay, just before it made some erratic movements in reverse and then forward, and I'm not at high magnification. You could see those movements much more when you move in closer. You can see, look at that, look at that. Okay, these are controlled movements. There can't be anything else. And like I said, I'm at low magnification. I'm going to move it back and move it in closer. Okay, it keeps moving to the north. That's not normal. It's not moving in the right direction, and it's right overhead. It's getting hard to put the camera on it because the stand just doesn't allow it. When I look at it just with my eyes, it looks just like an egg, the shape of it. And it looks very large. So I'm still around 100x. This camera does not have numbers, because I altered it. It has a line, so I'm making an assumption as to how many X I have. I know basically how many there are, so I'm judging by where the line is at. There is a little marker that tells me how far up the line I am. So I'm just sort of figuring out in my head where I am. I'm just adjusting the camera to try and get the image in. Okay, so the first thing I'm going to do is just check out different magnifications and which way it's moving and how much irregularities there are. Okay, see that's in reverse. Okay, so this is all, see that orb shoot by? This is all very strange and very irregular. There's some object following an orbital path to move in reverse. The only way you can do that is if you control the movement yourself, or some other being is controlling the movement, or a bunch of them. In this case, zillions of them, because they're cluster organisms, the orbs, and they all work cooperatively. In fact, they're the most cooperative things that I've ever seen in terms of working together. And they do that very well. It's a lesson we should learn from them, how to cooperate with one another, since they do it so well. Okay, so that shouldn't be happening, moving in reverse like that, or even up and down, or all those jumps. I constantly have to keep adjusting because it's moving. Look at all those orbs in the back. They're part of the dark matter supporting cluster. I have to keep making a lot of adjustments because it's moving fast. See, that's not even good enough. Even though it's making movements in reverse, it's still moving fast, going north. Top of the screen is north. And wow, that was a fast orb that just shot by. It went from top left corner to the bottom right. Let me just go closer. When you get too close, you can't get the orbs that are shooting by because they're so fast, and they're too close to the camera because I'm on high zoom right now. So they kind of just look like a blur when they happen. I can see a lot of large clusters. They're all active. The moon is still very bright. You can see how many large clusters there are there. In that area right there. And they're all very active. And the ones that are really bright, like white hot, the movement of the orbs inside of them and on the outside of them is at the speed of light. Wherever you see the really bright white hot areas, that means that the orbs in those clusters there are moving at the speed of light. Wow, just jumped right off the screen, now it's coming back. I got hands off the camera, didn't touch anything. You can see how fast it's moving. Okay, you gotta back it up. Reset. See there where it's very hot, white hot. You can see that the orbital speeds around the nuclei are greater than where it's not as hot or not as active. You can see the difference in the speed of the orbs. So the velocity is greater where the real hot nuclei are than where it's darker. But throughout the whole entire orb cluster nucleus, which is the moon hologram, it's still all the orbs are at a very high velocity inside that nucleus. It's just that some parts are more active than others and they have a greater velocity of the orbs. The entire nucleus itself is filled with smaller nuclei, which are just more orb clusters that are smaller than the nucleus itself that comprise the nucleus. And look at this, look at this. Okay, this is a really irregular movement tonight. See the orbs there? It doesn't want to show those orbs. I'm going to have to move it. Okay, I'm going to hold the camera I'll show them myself. Those are big clusters right there at the edge. Okay, that's not a crater there. That's a large cluster. And those aren't mountains, they're just a chain of orbs containing that cluster in the middle. Okay, which looks like a crater. But it's all orbs. Okay, everything there is just all orbs. There's nothing else. Okay, that's the... Wow. That wasn't me. I'm just holding it in one place. Okay. Something's there that I need to look at. Hold on. I gotta go back over here. I must have missed something important since it went right off the screen. Okay, that little cluster right there, as you can see the orbs going around it. Okay, that's another nucleus, but you can really see the orbs going around it. That's a real active one. See, right there too. Wow. It doesn't want to show that part. See? See when it goes off the screen like that? Now you'll move it back. When it goes off the screen like that, that means it wants to hide something. Okay, I have to readjust. Went too far. No. Okay, you see it's moving north. That's where I was checking. It's like right above my head. It's hard to set it. I may have to hold it. Okay, it's set. I go all the way in. Okay, now I'm at very high zoom. You can only see like a sliver of it. So as I was saying the other day, if it would only stay in one place, that red line, I have to move it. Okay, that I'm holding it. That red line is like a permeable membrane. It lets the orbs in from the greater cluster that's dark matter into the nucleus, and it lets out the orbs that are in the nucleus that are charged up out into the cluster that's dark matter, which is the supporting cluster for this moon orb cluster nucleus and the moon hologram. And if I can get the right angle, this is the cluster I'm talking about. It's hard to get the right angle. When I get it right at the point. Okay, so this is the point. Keep swinging so much. Okay, this is the cluster, the supporting cluster, and this is dark matter. And all that movement creates dark energy because the orbs are charged and interacting with one another. But it's also like a force field and a permeable membrane, and this thing is moving back. It just doesn't want me to see something there, but I don't know what it is. There's something there that is definitely important. Okay, you can see the orbs really going through the paces, charging up the whole thing. There's more and more energy being produced in the moon hologram and orb cluster nucleus, and the cluster in the back, the dark matter cluster, is getting larger because these things are increasing in population on an exponential level. So the more orbs there are in the dark matter cluster, the more get packed into the nucleus to be charged up. And that's how the nucleus glows brighter and brighter. And once it reaches a certain critical mass, I believe this is going to become a star, because there's only so many orbs it can take before it triggers off a chain reaction from all the energy that's being created, and then it'll get a star status rather than being just a moon. I mean, look at the brightness. That is definitely super bright. And look at all the active clusters all throughout. These places used to be very dark. Now you can barely see them. There's more and more active clusters everywhere. This whole side. The movement has become much more irregular than ever. Look at how bright that is. That's the kind of brightness you see when you take videos of the sun. Okay, that's really bright. Okay, so it's moved off. I gotta reset. Didn't do a good job there. Okay, so, oops, just went off the screen and I had it just where I wanted it. Okay, you see, it's really jumping around. It's hard for me to keep track of it without holding the camera on it. Okay, I got hands off the camera. That red line there, that's the permeable sort of force field, and it acts like a permeable membrane, and that's what lets in orbs in and out, but keeps other things outside. It doesn't allow them in. Anything foreign is not able to come in. Okay, so it only allows the orbs in and out. You can see the energy that it's putting out, and that's created by orbs moving at a super high velocity around the whole thing, counterclockwise. And there's actually a red band and a mustard color band. So there's a double layer of protection in that there's the energy, you can see it, and that's just charged orbs moving around at super high velocity. I'm holding the camera now just to show that. Okay. Okay, I got hands off the camera. This is the movement that it's making. Okay, I'm too close. I gotta back off to look at the shape of it. There's a good view of the shape of it. I'm just gonna increase that a little bit. Okay, so it's taking up the entire screen. So that should be about 100x. You could see the shape of it if I bring it up. So it's not round. Like I said, it looks a lot like an egg. And if you look at it with the naked eye, it really looks like an egg. and it looks big. Just looking at it with your eyes, it looks big. It looks a lot larger than it used to look, that's for sure. Okay, so that's the shape of the entire cluster, and it's been like that for the last week or more. Okay. There's been practically no changes in terms of either the brightness or the shape of it. I'm just gonna go closer so you can see how it's moving. Okay, it's still doing the reverse motion. It's still jumping around like crazy. Okay, and I believe that this is all due to all the high activity inside the orb cluster nucleus. This our moon and a hologram. Okay. This is all living matter, and it's in both physical and energy form. And this is the cluster that supports it, dark matter. And this is the membrane close up. And you see it? Well, if you get it just right. Is going off the screen. Okay. And there, you can see the orbs exchanging right through the membrane or the force field. Okay. When you do this, it's all about getting the correct angle in order to see it. And there's like, for everything you want to see, there's only one correct angle. And it's not easy to get it. You have to have a lot of practice. And you have to, first of all, know that it's there, that you can do it. So all you got to do is find it after you know that you can do it. You have to practice finding it. It takes a lot of practice to find it. It's not easy. Like you can look at that, or you can look at that. Okay, it's the same place. So it all depends on your perspective. There's a way to see dark matter, and you have to, figure that out. It's not that dark after all, and it's living matter and living energy, because these things are like living energy, and intelligent living energy at that. But since they can control energy, they can convert energy into matter, living or non-living, and that gives them the power and the know-how to create things whatever they want, because they have full control over energy. See all the orbs there? No mountains, no craters, no soil, no rocks, no sand, no water. It's just orbs. Orbs in the nucleus, orbs all around the nucleus. All of space, all of our universe is that dark matter, and this kind of matter that's visible. So between the two, they make up our universe and perhaps other universes. They make up all the dimensions, known and unknown, and there are a lot of dimensions that are unknown. So they make up timelines, although that's just a concept. In other words, they make up different points in space, which we call timelines. But they move so fast, they don't really exist in time. Like past, present, and future, to them is all the same, because they can move fast enough to be at any given point in space on that timeline, and therefore they're existing outside of time, but they are the components that make up all the space. Okay. It's just us that use time as a marker, because to us it's important. Like to some living things, time is important because we only have so much of it. But to organisms like these, time is irrelevant, because they don't have to worry about it. Every time I set it, it goes right off the screen. Maybe tonight's not a good night for filming it. It's definitely trying to hide something, and I haven't figured out what it is yet. But it won't even come on camera. Okay, it's a holding position. It's moving in reverse. It's doing everything Now it's blurred itself. That means it's increased its velocity, or velocity. Okay, so now you really can't see much because they're spinning around their axes and revolving around the nuclei in the moon, or plus their nucleus. They're so fast that it becomes a blur. Let's see if I go closer. To really get a good look at that force field right there, and you can see that there's motion counterclockwise from right to left, and those are super fast orbs. I'm holding it now. Okay, it's still moving around a lot. The only dark part left, but as soon as I put a camera on it, you see how it starts to get brighter and brighter. Watch. You can actually see the intensity increasing and the thing getting lighter and lighter. If I held it here long enough, eventually it would glow. Because these beings called orbs are very intelligent, and they know when I have a camera on them. That was another fast orb moving in front of the camera, that blur. There's something there that I need to figure out what it is. Okay, you see how the dark part there is activating? You see the white part inside of the black part? Okay, that means that the nuclei in there are starting to get hotter. And that's because I have the camera on it. So they're going to make it look just like that. I have to reset. It's gone so far over my head I can't get it in the right position. Right off the screen, right off the screen. Okay. What I'm going to do is go make it smaller, and just watch it for a while. Okay, it's really being stretched out, the whole thing. I think it's just got too many orbs in it. So it's definitely going to increase in size even more than it is now. Okay, so it's 5:15 a.m. At this time, the activity starts to get less and less, because obviously it's aware that people start waking up and going to work, and the early risers might see what's going on, because it's so large that it's even visible with the naked eye if it makes any sudden movements like it was doing before. So it's going to calm down, and it's going to just look very normal, even though it's larger, because most people don't even pay attention to it. And that's the advantage that it has. Nobody pays attention to things like this, and they should, because this is something that will eventually affect everyone. This thing turns into a star, it'll most definitely affect everyone. Okay, it's still doing the reverse motions. Okay, it still hasn't calmed down, but as soon as it starts to get light out, it will. It does that every time. Okay, so it's fighting to stay in place. And then it just shoots forward. And sometimes it shoots in reverse. So there's got to be a reason for all of that. And in my opinion, it's all the activity that's happening. Is causing it to jump around the same kind of activity increase is happening all around it, not just inside of it, like the dark matter around it, being that it's exponentially increasing in population, or the number of orbs is having the same kind of an experience or an issue, or it could even be a problem, but there's definitely a lot more activity due to the larger numbers. Let's try and get that. Okay, I'm holding it in place just to get this area. Okay, you can see all the orb clusters in there. There's some active or more active than others. The light ones or the brighter ones are more active than the darker ones. And you can see the orbs just spinning or orbiting their nuclei very fast. Okay, all this is in order to create more energy for the nucleus, more energy to charge all the orbs inside the nucleus, and to create more energy for the dark matter cluster that supports the nucleus. All the orbs in that dark matter cluster take turns in that nucleus to keep it going. Because if they were to stop, then there would be no more energy. And they would have to look for a new nucleus to go to, or to create another nucleus. One way or the other, there has to be a nucleus in order to keep the energy level or frequency maintained. You can see the difference right here between the white hot cluster nuclei and how much faster the orbs revolve around them, and over here the nuclei that are not as hot, and the slower motion of the revolutions of the orbs around them. Okay, so here's the difference right here. Trying to hold the camera as steady as I can. It's not just me that's moving. Okay. I'm holding it very steady with both hands. It's on a stand. But the nucleus is jumping around as well. So the point I'm trying to make is that the orbs revolve much faster around the glowing nuclei than they do around these, which are partly glowing, but not quite as much as these. Okay, you can just see the difference right there, one next to the other. I'll put them right next to the other, so you can even calculate the speed over here. Okay. here. They're moving so fast you can't even see them. And it's really jumping around a lot. I have to reset it. Okay, so that's the dark matter cluster. And that's all around it. Watch that for a few minutes. I'm going to cut this off at 1 hour because I don't want it to be too long. I'm at 57 minutes and 22 seconds right now. Okay, so you can see that the movement in that cluster is very fast as well. And you can't see all the orbs there because they're not all visible. Let me get the right angle. Hold on. It's not easy to get the right angle. You have to really work on it. And the right angle means the only correct angle. Because there's only one for each point in space that you want to get. There's only one correct angle and no more. Okay, so I got about a minute to go. I'm going to back it off. And I lost it. Okay. Okay, I'm going to let the egg run one more time. Let's see if we can see. Okay, I'm at 1 hour right now. 1 hour, 30 seconds, so I'm going to let it run a minute or so more and see if there's any, wow, it's still doing that movement in reverse. It's close to daylight. It's 5:30. At least that's what I have. I'm going to go a little closer so we can see them. There's one. This is me just checking things. But the movement and the jumping is the orb cluster nucleus. See how much the movement or the revolutions of the orbs has slowed down, because the activity or the frequency has come down, it's lower, so the intensity and the velocity is lower as well. That's the light intensity. And the velocity of the orbs is lower or less. So now you can see that it is all orbs and the way that they're moving. And here are those two clusters. See, when they get hot enough, they'll become one. Even that third one there and that fourth one on the bottom, they'll all unite to become one cluster. All of these, they're really at high frequency. Okay, there's always some at high frequency, you see, and that's what happened here. Wow, that was a big jump it took. So wow, it reduced the frequency right there just when it did that. Now you can see the big clusters that are creating that hot glow on that side. You see that? It's those two. And this one up here. There's a whole row of that one right there. And these two. So they were responsible for charging up everything else. This one over here as well. So they trigger each other off one by one until like the whole thing becomes just one white ball. And that's how it's going to become a star. It just moved off the screen by itself. See, there's a lot of areas, they're all calming down now. And you can see the orbs. Okay, so like I said, there's no solid ground. There never was, and there never will be. Even though these things can create inanimate matter because they control energy and everything, they're not going to do it there, because that nucleus is their energy factory, and it won't be happening on the moon hologram. Okay, so this was never a solid object. It was always orbs and energy, and orbs are energy, and they're living organisms, they're living energy. So there's another fast orb I just shot by. So I'm going to leave it right there, because I went too long. Just give you one more look at the dark matter. Okay, that's what's 90 or 85% of our universe is that. So when you travel through space, you think you're traveling through just black, empty void. You're traveling through them. Okay. So once you're out of the Earth's magnetic field or shield, then you're with them out there. Okay, there's lots of them on Earth as well. In our atmosphere, in our water, on the ground, in the trees, all over. Okay, they make the universe what it is, and we only see like 15% at the very most, and the rest of it we don't see, or we didn't see. Now I'm showing it to you, and like I said, there's only one correct angle to see any point with a camera that you want to see, but you have to find the angle. Okay, there's not 10 angles or 100 or 1,000. There's only one for each point in space, and that's important to remember. And once you know that you can find that angle, it's just a matter of doing it enough. It's a matter of practice, and you know what they say, practice makes perfect, and that's the way you get it. So if you're into this kind of a hobby and you like to use your camera for this reason, then you can try this for yourself. I'm sure you'll be successful if you give it enough time. So thank you for viewing, and have a good morning. It's close to 6 a.m.